This example asks us to solve x less than or equal to 0 and x greater than or equal to -2. We will solve this using both graph notation and interval notation. So let's start with the graph. X less than or equal to 0 is all the numbers smaller than 0. So let's go ahead and put on our 0 here. And then the numbers smaller than 0 are down this way. So all this stuff. Now, I put on this bracket, call this a hard bracket, or just a bracket instead of a parentheses or a soft bracket. This business means that we're including 0. If this was just less than 0, we would do a parentheses like this and go down. Right? Other ways to do it is a closed-in circle and down, and then an open parentheses would be equivalent to an open circle and down. Okay, so there are different ways of doing this, and you're more than welcome to pick your favorite. Okay, a little trick to do this: when the variable is on the left side like this, you can use this less than symbol. If you draw this little line right here, it tells you which way the arrow goes. It's not mathematically sound whatsoever. It doesn't mean anything really. It's just a quick trick to make sure your arrow has gone the right way. You can see which way the arrow should go by adding in that little leg in the middle like that. Okay, x greater than or equal to -2. Okay, so now we are saying, all right, -1, -2, and we want all the stuff bigger than or to the right of -2. So I'm going to go back here, and now we're starting at -2 and going off to the right. But and is the overlap, right? And is the overlap. So this expression is only referring to where these two overlap. So the solution in graph notation is only the region between -2 and 0. Just the stuff in between. So there's the solution in graph notation. Let's convert this to interval notation, which is how we usually represent these kinds of answers. Interval notation is always a representation of what the graph would look like. It's a shorthand because it's long to draw these graphs. We have all these shapes, we have the number line, all that stuff. We don't want to have to draw all that. So interval notation is a way of representing what's already on the graph. So it starts at -2 and continues up to 0 and then stops. Let's try another one. Here we have x less than -2 and x greater than 0. Okay, let's get our number line. And now we have everything less than -2. So to the left of -2, so here's 0, -2 is here. And I'm going to do a soft bracket or a parentheses here to say this is not including -2. It gets up infinitely close to it, but does not include it. Again, you could also draw this with an open circle here. That's another way of representing it. Okay, and then we go on down to the left. All right, there's that. And it just keeps going forever. Okay, also we have, so and x greater than 0 is all this stuff to the right of 0, all this stuff bigger than 0. Again, because there's no equal sign under that inequality, we use the soft brackets or the parentheses. We go on off to infinity this way. But there's a problem here. Remember, and is the overlap, right? And is always the overlap. And look at these two sides of this. Do they overlap anywhere? They don't. There's no overlap to these two. So the answer to this one is not this graph, but it's actually just the empty set. It is the set with nothing in it. There is no thing that those two inequalities share in common. No numbers. Let's try another one. Here we have x greater than or equal to -4 and x greater than 1. Let's start with our graph notation. X greater than or equal to -4 is all the numbers bigger than -4. So we'll say this. I like to use 0 as an anchor point. 1, 2, 3, 4. So here's -4. And again, remember, we can draw this little line right here to tell us which way the arrow should go. That works if the variable's on the left-hand side of the inequality. We use the closed bracket, the hard bracket, because it is not greater than 4, it's greater than or equal to 4, and off it goes to infinity. We also have x greater than 1, so here's 1, and we're doing all the numbers bigger than 1. And this is open parenthesis because there's no equal sign under there. And off we go to the right. Okay, but this is an and. And is only the overlap. So these only overlap on the numbers greater than 1. Right down here, there's no overlap down here. Right, it's only stuff that's greater than or equal to -4 down here. So we're going to throw that out and only include where they overlap. That is a very big marker that I'm writing with there. Okay, so let's do that. We just have 1 up to infinity, like so. That's the overlap. Okay, down to our interval notation. Interval notation is just a way to represent what we see on this number line. So I'm going to use my soft parentheses here, my soft brackets. I'm going to start at 1, and this says it just keeps going. So I'm going to say 1 comma infinity. Right, this tells me I start at 1 on the left and I go off to infinity on the right. If you have infinity in your parentheses for an answer like this, it always has to be on the right side, because plus infinity is out here. Similarly, if you have a negative infinity, it would have to be on the left side, because negative infinity is always on the left side of the number line. So your interval notation should mimic exactly the number line.